One of the most misunderstood and misused concepts in math is fractions. It is the concept that makes students freeze. It is the skill that so many adults still don't feel confident about. And now, AI will just give kids every answer without them ever thinking about what a fraction is. But as educators, we know that fluency with fractions isn't about memorizing rules. It's about understanding what they mean, how they behave, and how they show up in the real world. So, in today's episode, we're going to break down exactly how to use AI to help students build fraction fluency that sticks while keeping the thinking right where it belongs in the student's mind. We begin with intuition and not instruction. Do not start with the rule, start with the story. For example, you and three friends are sharing two pizzas. What does each person get? Then, what if one pizza is cheese and the other has pineapple? How would you change your thinking? These situations unlock the meaning of fractions before introducing notation. Now bring AI in. Ask AI to explain what's happening in this pizza problem and compare it to your thinking. Then follow up with, what did AI help you understand better? What do you still need to visualize or figure out? Then we can have students make prompts for models and visuals. Ask if they live on a number line or in shapes or in measurements. So instead of showing students pre-made visuals, you can have them prompt the AI to draw a number line showing 3 over 4 and 5 over 8. Create a visual showing how 2 over 3 plus 1 over 6 works, or compare these two fractions with images. Then you can ask the students, what do you notice? What looks correct? What looks incorrect? How do you know which is greater? Students are building visual reasoning with AI as a sketchpad. Then you can help build conceptual comparisons, not just calculations. So instead of adding 1/4 plus 1/3, you can try first which is larger, 2/5 or 1/2. Then you can have them ask AI to explain both sides. And you can ask them, do they agree? And have them use AI to show 3 different ways to compare 3/4 and 7/10. Then ask AI to explain which explanation made the most sense, and then ask them, can they create their own? Now they're analyzing and not just accepting. You can then go to design error analysis tasks that are powered by AI. You can have students prompt the AI by asking them to show a common mistake someone might make when subtracting 3/5 from 1/2. Then you can have them explain what the mistake is, explain why it happens, fix it, teach it back. This is fluency built on reflection and correction, not just repetition. Next use, real-world synthesis challenges. Have students design their own context, creating a recipe that uses 5 fractional measurements. You can ask AI to convert it for double the servings and ask them what do they notice. They can design a sports drill where 3/8 of the time is spent running and 5/8 of the time is spent on skill work. And you can have them use AI to build variations and reflect on the math behind it. And here now, they're just not solving, they're building, they're adjusting, and they're justifying. Next, you can have them make fluency visible through journaling. You can have students write what I thought I knew about fractions, and then what AI helped me understand. What do I still find confusing? How I explain this concept to someone else. This creates metacognitive fluency, which supports long-term retention. You can then have students create multi-layered fluency tasks. You can structure it like this. Explore the concept, where you're asking AI to explain how to subtract fractions with unlike denominators. They can write down 2 things they didn't know before. They can practice strategically, where they have to solve 3 problems, and they can ask the AI to help them with this by showing how to perform each step and describe the reasoning, not just the answer. They can apply in context, where they're asking to write a word problem using the fraction operation you just practiced. Solve it in 2 ways, with AI and your own steps. Reflect on that process. And they can write out, how did AI support their understanding? Where did they rely on it too much? Each part develops a different layer of fluency. And finally, always reinforce judgment with a rubric. You can have your sample scoring guide with 30% for clear reasoning and explanation, 25% going to accurate use of fraction operations, 20% evidence of comparison, critique, or correction, 15% real-world application or problem generation, and 10% for reflection on AI use. Students now know fluency is not about speed, it's about depth. AI will always be able to solve 5 over 6 plus 3 over 4, but it cannot make a student understand why common denominators matter. It cannot see the connection, it cannot feel the meaning, and it definitely cannot build confidence that lasts beyond the test. Your role now is to help students use AI to reveal the patterns, not skip past them, to see what fractions really represent, not just punch them into a tool. Because when we use AI to support curiosity, comparison, construction, and critique, we don't just build fluency, we build thinkers, and that's what fraction mastery really looks like.